channel. From my previous video, you should have some idea differentiate between the convex and concave lens. By convex because it's bent out, convex, and by concave, cave into it. The cave, right? Cave in, right? So we bend in. Okay, so you have concave, cave in, bends out, convex. V-E-X, wax, convex. Then this is called the principal axis that cut through them for these two different lenses, and you have your focal point F. It's a mere. This is 2 times the focal point, where this is the origin, and then this is the focal point. This is the focal point, double focal point, right? So that's all about it. And then yeah, okay, you have a focal point for convex, concave. I think you have gone through the your reading by now, because you should. Otherwise, you are not supposed to watch this video. Every video you should come with reading and exercises. If you have watching this video, meaning you have gone through your reading about the characteristic of object and image at different location and various location. How is it? As I explained from a previous video. And then just like I have shown, say for example, if I have an object, okay, in between f and 2f, well, it's not up to scale, and you are always nice to really practice it on a piece of graph paper, as I mentioned. So we are not going to go through what I have gone through. So basically, this is what I want to talk about, where a short revision. So you have an object. So what happened? Principal axis. If you were parallel to principal axis, what happened is it will bend towards the focal point, right? When it pass through O, then it will go through it, right? Well, it's not at the right. Now I'm not drawing it up to scale, so this is. You have an image slightly bigger. Okay, real, inverted, magnify, and it's at opposite side. This is the object. This is the image. This is the image side. Okay, when object and image is the opposite side, this is what I'm going to talk about in this video. And the same goes with this side. Object parallel to it. What happened? It will be focused at here and then out, right? Converge. It's a straight line here. Okay. Parallel to it, then it will focus at the focal point at the same side with the object. It will pass through the origin, then it will just pass through it and the ray, right? Okay. This is ray diagram, how you normally draw it. And of course, there's another F here. Then we focus at F. This is the one that normally students miss out. And then the line that they cross somewhere here, this is your image. Same line to it. Okay. This is object. This is your image. So for concave, the image form at the same side with the object. So here, maybe I'll just summarize the two and into one. So you might just want to practice the ray diagram, because the second video is about ray diagram. This is the third video. In third video, we're going to use what you have learned in previous video. So what happened now is we want to calculate what's the power of this lens, these two lenses. Okay, power of a lens. What's the power of a lens? Power, symbol capital P, power. The unit is in diopter. We put it in capital D. I mean, maybe I'll spell it because since it's the first time we're doing it. Power down there later. Okay, unit. A special unit called diopter. D. I think you have seen this term if you are into photography. Okay. Capital D is a unit. Okay. So, what is power? Power is actually the ability. Ability is a measurement of the ability to concave or converge or diverge an incident beam. Ability is a measurement. It measures, yeah. Sorry. I think it measures. It measures. It measures its ability. You may translate into BM if you want it. Ability to, this one for this case is converge. Better to learn this term. Or for concave is diverge, mencapai. Converge or diverge. And incident beam of light. Okay, you have light incident, light converge, this diverge, mencapai, or menuju, converge. This is you get a real image, this is you get a virtual image. Okay, so without not so much of wording, how does it work? How the calculation work? It's simple. Okay, whenever question give you ask for power, power is actually 1 over the focal length, measure as in meter. Okay, if it's not meter, convert it to meter. If you're given a centimeter, so your power, therefore you convert it is actually 100 over the focal point as in centimeter. Okay, depends which is given, but this should be the equation. Okay, and or the unit is diopter, or is per meter. Okay, it's easier for to understand, it's per meter. Say for example, okay, question. You're given a focal point is equals to 20 centimeter, focal point of a lens. Okay, then what's the power? Power would be therefore given centimeter, so it's 100 over 20 unit diopter. So it's actually plus 5 diopter. Positive means is a convex. Okay, convex lens. Okay, in some structural question, you need to identify them. Okay, so also we define when it's an image site. Image is everything. The distance from here to here is u. Distance for the image site is v. Okay, don't confuse yourself with kinematic in chapter 2 where u is velocity. No, in physics chapter 5, light, u is the distance of the object from the origin. Okay, so when it's positive, meaning it is convex lens. This is positive. From here to here is positive. here to here is positive, and here to here is positive u. Here to here positive v. Okay. Next, there have 2 more to go. You have power. You have linear magnification. Linear magnification. Now, so what linear magnification does is again from the ray diagram. So in some structure question, in SPM, magnification. Okay, unit small m magnification. So what's the equation actually? Magnification is actually, all you need to do is you use image over object. Okay, the height of an image, over height of an object. In the event, they give you the height, or the distance, the image distance. This is obviously the image distance. V is image distance for you to refer. U is the object. Okay, you might be want to know how you get to this, but for SPM wise, if you get to here, it's good enough already. Magnification, that's the equation. The basis for how they get it is actually from a triangular, a congruent triangular, because here to here, this triangle, to here, the triangle, they are all congruent. Okay, meaning this side and this side is the same, this side is supposed to be the same. Okay, so based on a convex lens. When things get into a concave lens, all you need to do is apply a negative value. When it's negative V, then you know this is a concave lens. Okay, I'll leave you to the question. That's when you go along those question, chapter by chapter question about this magnification linear. I think you have some idea what I'm talking about. For now, just for you to jot some notes here and there, or watch my video, pause it, do some exercise, and then you come back to the next chapter. I mean the next subtopic is called lens equation. Lens maker equation. Lens equation. What is lens equation? This is the same equation used for making a pair of glasses to wear. It's only for thin lens, but the equation is I think 1 over u plus 1 over v is equals to 1 over f. So it's everything's 1 on denominator, and denominator would be is u, v, and f. Okay. You doesn't need to go anything further than that. I mean, as long as you know how to use it. 1 over u is the object distance. V is the image distance. Be careful of the sign. It's possible to use for both different types of lens. F is the focal length. Okay, focal length. When V, please take note, when V is negative, meaning it's a virtual image. A conclusion is a virtual image. It helps you in your structure question. Meaning, what does it mean virtual image? Meaning it have the same side. Same side as the object. When they have same side with the object, like this case, then the image should be virtual, meaning you can't form it over the screen. Something special about this equation, of course, you may bring around them, times v times u, and then simplify them and do some maths on it. But for the physics part, it's 1 over u plus 1 over v equals to 1 over f. Okay, where u is the object, this is the object distance, v is the image distance from from the origin. Always measure from origin. F is the focal length. If u is given centimeter, make sure your v is centimeter, f is centimeter. Make sure your unit is consistent. If you are using the unit for f is meter, be sure v is meter, u is also meter. Be be sure your unit is consistent. That's the basic law of physics. Okay, so that's all about this part. So what you need to do is just like the others. What you do is stop or pause this video, go through the questions. If you can't do those questions, you go through your reference text, look for this section, and you're advised to at least try 30 questions for these three parts. We need 10 questions each on power, linear magnification, and lens equation. No one sets you limit to only one publisher. You can have different publisher and try their chapter by chapter questions, at least 30 questions in a week time. Okay, then only you proceed to the reading. I think this will be the last part for this chapter, where I will also advise you to look through the difference between microscope and telescope. What's the difference? Set up a table to compare microscope and telescope, the object lens, the eyepiece, how their arrangement of lenses. Okay, normally it comes up in your essay questions. You will compare the difference. So with that, if it benefits you this video, kindly press on the thumbs up button as a token of appreciation from you to me, or follow my YouTube channel for more upcoming videos. That's all from me. Good luck in trying your exercise question. Thank you.